Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello subscribers, viewers, and students. Here is another sample problem video in calculus, a problem which you might encounter in your engineering life. I hope that it will help you in your studies in engineering. If a ball is thrown into the air with a velocity of 40 feet per second, its height in feet after t seconds is given by y equals 40t minus 16t squared. So part A, find the average velocity for the time period beginning when t is 2 seconds and lasting I 0.5 seconds, 2I zero point 1 second, 3I zero point 0.05 second, and 4.01 second. Then find the instantaneous velocity when t is 2 seconds. By the way, for those who want to anticipate the solution to this problem, you may do so by pausing the video. And that should be the good attitude for viewers and students so that you will learn by your own. So this average velocity is simply delta y over delta t. And delta y is the value of y when t is 2.5 seconds because the base time is 2 seconds, and for part I 2.5, for part 2 it's 2.1, part 3 2.05 seconds, and part 4 2.01 second, and the base time is 2 seconds. So y when t is for part I 2.5 minus y when t is 2 seconds. Then divide by delta t, and delta t is simply zero point 0.5 seconds, or 2.5 minus 2. So a point I, the average equals delta y over delta t, and delta y, as I said, is the value of y when t is 2.5 seconds less the value of y when t is 2 seconds, and delta t is simply this value of time, zero point 0.5 seconds, or 2.5 minus 2 seconds. 0.1 second is 2.1 minus 2 seconds, and so on and so forth. So it is 40 times 2.5 minus 16 times 2.5 square minus quantity 40 times 2 minus 16 times 2 square all over zero point 0.5. Again, zero point 0.5 is 2.5 minus 2. Or simply, you just put put in the denominator this time. So using your calculator, it is negative 32 feet per second. So A.2i, the average delta y over delta t. So it is equal to quantity 40 times 2.1 minus 16 times 2.1 square, then minus quantity 40 times 2 minus 16 times 2 square all over zero point 0.1. So the average velocity is negative 25.6 feet per second. Then for part 3, uh, average velocity is quantity 40 times 2.05 minus 16 times 2.05 square minus quantity 40 times 2 minus 16 times 2 square divided by 0.05. And the average velocity is equal to negative 24.8 feet per second. Then 8.4 average velocity delta y over delta t, and it is equal to quantity 40 times 2.01 minus 16 times 2.01 square minus quantity 40 times 2 minus 16 times 2 square all over 0.01. So the average velocity is negative 24.16 feet per second, and this is the closest time to 2 seconds. So therefore, we anticipate that the instantaneous velocity when t is 2 is negative 24 feet per second, but you have to verify that. So for part B, the instantaneous velocity is obtained as the value of the limit of delta y over delta t as delta t approaches 0, or simply dy dt. So we will evaluate that as the limit of delta y over delta t as delta t approaches 0. So y plus delta y equals 40 times t plus delta t minus 16 times t plus delta t quantity square. So delta y is equal to 40t plus 40 delta t minus 16 times quantity t square plus 2t delta t plus delta t square, then minus quantity 40t minus 16t square. So 40t will vanish and negative 16t square, and we have positive 16t square will vanish. So delta y therefore is equal to 40t plus 40 delta t minus 16t square minus 32t delta t minus 16 delta t square minus 40t plus 16t square. So we can cancel 40t minus 40t and negative 16t square and 16t square. So delta y equals 40 delta t minus 32t delta t minus 16 delta t square. Then we divide delta y by delta t. So delta y over delta t is 40 minus 32t, then minus 16 delta t. So the limit of this as delta t approaches 0 is the derivative of y with respect to t, and that's the expression for the instantaneous velocity. So v, which is dy dt, is equal to 40 minus 32t, and the limit of this expression, and that's equal to 40 minus 32t. So when t is 2 seconds, so v is 40 minus 32 times 2, so v is equal to negative 24 feet per second. So that's it for this video. I hope that you were able to understand the explanations, the solutions, and thereby in the future you can solve the problem in calculus, particularly on velocity.